Contamination. Prevention and control. When component changes, or work is performed on the machine, make sure that all new components are free from contamination, and that further contamination does not enter the machine during servicing. In this video we discuss desiccant breathers. Desiccant breathers remove contaminants, such as dirt and moisture, from air entering machinery, sumps and reservoirs. Choosing the right breather. When choosing the right breather, you have to take a number of factors into account. Point 1. What is the environment? Your machine's operating environment should be considered, as it pertains to the amount of contamination. Humid work environments tend to shorten the lifespan of a desiccant breather. The more humidity, the faster the silica gel reaches maximum moisture holding capacity. Because, once the capacity is reached, and no more moisture can be removed from the incoming air, it's time to replace the breather. Point 2. What is the application? Well, the application refers to the type of equipment needing a desiccant breather. Breathers come in multiple sizes and series. It all depends on what machinery you have, or kind of plant you are operating in. Let's look at the various application categories and the type of breather, which can be applied. To start with, the disposable or stationary applications. Disposable and stationary applications include stationary fluid handling tanks, hydraulic reservoirs, transformers and gases. Air Sentry D-Series breathers are designed for these applications. The D-Series replace the standard vent, filter cap. There are 8 standard models. The Z-Series are designed for applications with space limitations, or minimal airflow requirements, such as gearboxes, totes, and small oil containers. There are 5 standard Z models. The X-Series is designed for extreme humidity and dust applications. It incorporates check valves in the reusable top cap, and replacement cartridges. There are 13 standard models. The R-Series breather is designed to withstand continuous vibration. It incorporates a metal-reinforced base and a replaceable cartridge. There are 8 standard models. The XR series combines the key features of a metal-reinforced base and check valve technology. Used on mobile lube and fuel equipment, farm implement reservoirs, windmills, etc. There are 15 standard models. The M-Series is designed for heavy-duty applications, such as off-road, mobile equipment, construction equipment. There are 5 standard models. And last, but not least, the Guardian series fit for almost all applications, such as remote equipment with long service intervals, wind turbines and offshore platforms. More info on the Guardian follows in a separate video. So, back to the choosing of the right breather. We arrived at point 3. What is the average and maximum airflow rate? The breather size is always determined by the maximum fluid movement in and out of the fluid reservoir. Always choose a breather with a higher CFM capacity than the CFM requirement of the tank or reservoir. CFM means cubic feet per minute. Not all equipment may specify a cubic feet per minute value. For example, gearboxes. Install desiccant breather without enough airflow creates excessive pressure, causing a vacuum, which will damage the equipment. It is very important that the breather doesn't restrict air to the point it creates lubricant flow issues within the system. And finally, point 5. Is the operation intermittent or continuous? Desiccant breathers are rated for either continuous or intermittent flow. This is usually important when it comes to whether the breather incorporates check valves to aid in the life of the breather. Brief explanation of the check valves. If no check valve is available, exhausting air flowing from a fluid reservoir can bring oil mist, heavy vapors or moisture to contaminate the silica gel. With a check valve, the isolation check valve functions as a barrier to oil mist, heavy vapors, splashing oil and moisture. The 4 check valves in the top cap open at 0.1 psi, provide redundant airflow into the reservoir. The 4 check valves in the base open at 0.1 psi, allowing existing air to bypass a reverse path through the silica gel. The lifetime of a desiccant breather. Most breathers last anywhere from 3 to 6 months, provided it is properly sized, and depending on the number and volume of air cycles passing through the silica gel. How much silica gel is in the breather? In the environment, and the contamination in the lubricant, when the initial breather is installed. Each time a piece of equipment breathes, water vapor is retained in the silica gel, gradually shortening the life of the breather. The amount of water the can hold directly relates to the amount of silica gel in the breather. Most desiccant breather manufacturers have a chart with the maximum water capacity for each breather, so you'll know how much moisture the breather can retain before reaching the end of its life. Humid work environments tend to show the lifespan of a desiccant breather. This is because, as the humidity increases, the silica gel reaches its maximum moisture holding capacity faster. Once this capacity is reached, no more moisture can be removed from incoming air. How to improve the life of a desiccant breather? It's advisable to use a breather with check valves, for instance a Guardian model from Air Sentry, in intermittent flow applications. With check valves, only the air that needs to be inhaled in is dried, lengthening the life of the silica gel. If possible, increase the distance from the bottom of the breather to the top of the reservoir by adding a small length of pipe in between. This keeps the breather free of oil mist coming out of the reservoir. Source.